Am I audible? Good morning, everybody. Am I audible? All right. So I'll just wait for 1 or 2 minutes and then we can start. All right. Are there any questions from my previous lecture? Priyamvada, do you have any question from my previous lectures? All right. So if there are no questions, then all right. So I'll start with the lecture. Right. Since today is October 3rd and we celebrated Mahatma Gandhi's birth anniversary yesterday, I will begin today's lecture with one of the very curious historical findings about Mahatma Gandhi's interest in astronomy for a brief period. And for this, I am indebted to Dr. Ratnashri, who has been doing research in this area. And I also thank her for sharing some of the slides for the lecture today. And for details, you can read an article that was published, author being Dr. Ratnashri, director, Nehru Planetarium. Now, it so happens that Mahatma Gandhi, when because of his involvement in freedom fighting, when he, along with Sardar Vallabhbhai Patel, Mahadev Desai, and Kaka Kalelkar, they were imprisoned in Yerwada jail in Pune. Kaka Kalelkar, who was an avid amateur astronomer, he showed some of the constellations to Mahatma Gandhi when all these four freedom fighters were in Yerwada jail. And Gandhi was immediately taken up by the grandeur of the night sky. And he also started reading books on astronomy. In particular, Mahatma Gandhi read Maunder's book with the title Astronomy Without a Telescope, and he was deeply impressed by the book. And in particular, one of the definitions of science that Maunder had given in his book, namely, science is accurate measurement. Mahatma Gandhi was very deeply inspired by this sentence, and he, in fact, incorporated the idea that science is accurate measurements. He incorporated this idea in his day to day life. And since he got fascinated by the night sky, he looked at the Orion and he did his own sketches. So, in this slide, you can see on the left the sketches by Mahatma Gandhi, and that has been overlaid on the actual Orion constellation by Dr. Ratnashri. And you can see that Mahatma Gandhi was fairly accurate when he did this uh, sketching of the Orion constellation that he observed with his naked eyes. Furthermore, he also took keen interest in observing the Subtershi. As you can see, there is the actual Subtershi constellation goes like this, and Mahatma Gandhi's sketches, the brighter ones are the sketches made by Mahatma Gandhi, and that has been overlaid on the actual Ursa Major or Saptarshi. There are certain deviations, as you can see. So you can try to rotate it and try to fit it, but it will not fit exactly. Similarly, the Ursa Minor, where one of the end stars is the pole star Dhruvatara, and for the sake of comparison, this has been artificially brought closer to the Saptarshi. Actually, Ursa Minor is somewhere in this location. All right. So within the naked eye errors, you can see Mahatma Gandhi's sketch of Saptarshi is fairly accurate. Right. Now, uh, of course, this is not surprising. Who would not be captivated by the celestial grandeur that the night sky presents to us? And we know that in the early civilization, whether it is Mesopotamian civilization, Indus Valley civilization, Egyptian civilization, Vedic civilization, or Chinese civilization, the night sky certainly captured the imagination of our early ancestors. In fact, the people of Mesopotamian civilization were extremely interested in astronomical observation. And here is a clay tablet with cuneiform script. As you know, Mesopotamians, like Babylonians and Assyrians, they used a script which was similar to different shapes of triangles, and that is the reason why their script is called cuneiform script. And one of some tablets, Babylonian tablets, which are extant in the British Museum. By studying such tablets, F.R. Stephenson, K.K.C. Yao, and H. Unger, they published a paper in the journal Nature, volume 314, in the year 1985. I suggest that all of you must read this paper. In particular, this paper also talks about astronomical records, which are part of historical records of astronomical pursuit from China, from Korea, from Japan. So please look at this paper. This is a very fascinating paper that was published in Nature Journal, in which the authors did analysis and showed that the script text and the detailed observation most probably refer to Halley's comet when it was sighted in 164 BC and then later at 87 BC. As you know, Halley's comet has a period which is between 72 to 75 years, as the comet has an extreme comet moves in an extreme elliptical orbit, and when it comes close to the focus, remember the Kepler's law that we discussed in the previous lecture? We said that according to the Kepler's law, sun will be at one of the foci, and objects orbiting the sun would go around the focus, and for objects that move in highly eccentric orbit, there'll be a semi-major axis and there'll be a semi-minor axis. The semi-major axis is, of course, very long for the Halley's comet, but when it comes very close to sun, then we can start observing the comet, because the solar radiation, both the electromagnetic radiation as well as the solar wind, the radiation pressure, they cause the gaseous substance which are part of the comet to be swept away from the direction of the sun because of the solar radiation pressure as well as the solar wind, which exert pressure on the gaseous objects so that they are, in a sense, driven out radially outwards from the sun's direction. And that is the reason why when a comet starts approaching the sun, it develops a tail because of the radiation pressure from uh, solar luminosity as well as solar wind. The Mesopotamians were particularly a group of astronomers were avid watchers of the sky. In fact, the king had employed a set of people to make daily observations of the night sky and maintain a diary. And the authors of this paper, they actually looked into the diary. Of course, the diary was maintained in the form of clay tablets on which the texts were in the form of cuneiform scripts. Now, you might wonder that apart from the grandeur of the night sky, was night sky useful to our early ancestors? And what could have been the use? Now, remember that Mesopotamian people as well as the Indus Valley people, they were very efficient seafarers. In fact, we have historical evidence that the people of Indus Valley, they used to have trade relation with Mesopotamians. So both Mesopotamians as well as the Indus Valley people, they used to travel by means of boats and ships. And we know that in the old times when the magnetic compass needles were not around, as you know, compass needles were made use of only by the Chinese people, Chinese sailors, much later. But before that, one of the ways with which Mesopotamians, Indus Valley people must have navigated was to use the constellations, in particular the Polaris or the pole star, because Dhruvatara, as it because of the axis of rotation of the Earth being directed towards the Dhruvatara, as Earth rotates, as the night develops, the position of Dhruvatara doesn't change, and hence the seafarers could use the Polaris or the Dhruvatara to make judgment regarding the direction. So let's have a look at the great civilization of Mohenjo-daro. As you know, uh, the Harappan civilization, they had, of course, the earliest excavated cities were Mohenjo-daro and Harappa. Currently, these two Harappan cities, they lie in the country of Pakistan, but there are several other Indus Valley cities that are part of India, namely Lothal, which is about 3 hours journey from the city of Ahmedabad in Gujarat. And there are Kalibangan and many other Harappan cities scattered all through in the northwest region of India. And as I mentioned in my previous lecture, that all these early civilization sprang at the banks of mighty rivers because water is not only essential for survival of human beings to quench their thirst, but also water is needed to irrigate the fields and to carry out farming. And we all know the significance of agriculture and farming for the rise of civilization. Before the concept of agriculture was came to human beings, they were hunter gatherer. They used to uh, look for food and water by sort of going from one spot to another, hunting, plucking fruits from trees, etc. And because of this, all the people of the ancestral tribe, they were involved in gathering food and water. But with the onset of agriculture, a group of people, they were assigned to do the farming, and the product of the agriculture like grains, paddy, wheat, barley, etc. They were, once they were grown, they were stored, and the other set of people, they had enough time to pursue many other activities. That is the reason when agriculture started, there was time for human beings to indulge in architectural pursuit for languages, for sketching, for literature, for building tools, and essentially the beginning of technology started only after agriculture became common. And that's the reason why rivers and the cities that grew at the banks of rivers, giving rise to early civilization, is so very important. And with the rise of civilization, trade also started, and trade between different civilization required often sailing from one port to another. And as I mentioned shortly before, for sailing, astronomical objects played an important role in uh, coming to the aid of the seafarers as they could be used for navigation. One of the remarkable things of Harappan or Mohenjo-daro cities is that the houses and the streets of Harappan and Mohenjo-daro cities are aligned in the cardinal direction. That means north, south, and east, west. So, north, south, and east, west direction, the alignment suggests that Indus Valley people were keenly monitoring the uh, sky for deciphering proper directions. Furthermore, as I mentioned, Indus Valley people were avid seafarers, and here are some of the impressions on the seals. For example, this is an impression taken out of a broken Harappan seal, and as you can see that it is that of a ship with a proper shelter for the sailors in the middle of the ship. All right. And in the lower figure, you can see another instance of a large boat, again with a central shelter for the sailor. What is interesting is you can also see the seabirds. Their sizes, of course, have been exaggerated in the seal, and the fact that the seabirds, like seagulls, have been portrayed shows that the this particular impression, which was found in an amulet discovered in the ruins of the Indus Valley cities, uh, shows the keen observation of the artist who essentially made this impression on an amulet. There are speculations that the Indus Valley people also took interest in the celestial sky. Here is one seal which has caused several speculation from uh, Indologists like Professor Asko Parpola, and then by the TIFR group led by Professor Mayank Wahiya. Look at this particular Indus Valley seal. Here, you have a central figure amidst the sacred tree, and you might be aware of such a figure in a yogic posture in other seals that have been found in Harappan civilization. Those seals refer to the central figure sitting among the sacred tree with people like leaves, and those seals in which the sacred figure is seated in a yogic position is called Pashupati seal, because Pashupati seal, they are often depicted with lot of animals present around the seated figure in a yogic posture. And many historians believe that the the Shiva, Lord Shiva idea came from the Indus Valley civilization, where the sacred sacred uh, deity in a posture, yogic asana posture. As you know, Shiva is also associated with yoga, and it is believed by many Indologists and historians that the Pashupati seal suggests that Shiva was a deity of the Indus Valley people, uh, which is distinct from the Vedic deities who are mentioned in the Rigveda, which who were worshipped by the Indo-Aryans. Now, coming back to this seal, there is this seal, of course, reflects a lot of intriguing features, like there seems to be a head priest bowing down in front of the deity amidst the sacred trees. And then there is a uh, ram like animal. And then below, there are these seven figures. And it has been suggested by um, some of the uh, historians and archaeoastronomers that the ram like figure might be representing the Aries constellation, while the seven figures here might be either depicting Subtershi or the Pleiades constellation. As you know, in Rigveda, Pleiades is referred to as Kritika Nakshatra, right? And uh, therefore, uh, the archaeoastronomers and Indologists, they suggest that indeed Indus Valley people also did uh, a study of the celestial objects in the sky. But I must here underscore that these are speculative analysis. The reason being that no one has yet deciphered the scripts of Indus Valley. For example, here are certain instances of the script. Very often you see a fish shaped script and a jar or U shaped symbol in the Indus Valley script. And although uh, the Indologists like Askopopula, late Airavati Mahadevan, and later the TIFR group and Institute of Mathematical Science group, they have done analysis and they seem to conclusively suggest that these scripts indeed correspond to a language, but no one has yet deciphered the Indus Valley scripts, and therefore we really don't know what exactly these figures depicted in the seal, what do they represent really? So that's the reason at the moment one can only speculate. Right, now let's go on to astronomical studies concerning the Vedic era. As you know, uh, Rigveda is one of the oldest texts as far as Indo-European literature is concerned. In fact, Rigveda being the oldest Indo-European literature essentially motivated several Europeans like Max Muller, Renaud, Thibaut, Jacobi, and many others to take great interest in learning the nuances of Sanskrit language and studying Rigveda so that they can have some glimpse of the history of Indo-Aryans who were supposed to have lived originally in the steppes region, and then from there they started migrating in different directions, and that's because they were the early inventors of light chariots. That means chariots with spoked wheels, and the chariots were very light so that they can be driven fast by horses. And the Indus, the Indo-Europeans and the Indo-Aryans are supposed to have domesticated the horses for the first time, and they could therefore move very fast on light horse-driven chariots. And the historians believe they started from the steppes region, now in modern Russia, and very close to Volga River, and they migrated in all directions, forming the present-day Europeans, Iranians, India, the Vedic Indians, and also there is evidence that in the Turkey region, a part of Indo Aryans had settled, because there are evidence from manual to train the horses in language which is very close to uh, archaic Sanskrit. Now, in Rigveda, there are hymns, there are shlokas to the twin gods, which are referred to in Rigveda either as Nasatyas or Ashwins. And they, of course, correspond to the astronomical objects Beta and Gamma Arietis. And in particular, the shlokas of Rigveda mention that Ashwins are the earliest deliverers of light. What they mean is that normally, as the earth rotates, before the sun rises, very often it is this Beta and Gamma Arietis, they appear to rise at the horizon in the east. And perhaps because of that, Rigveda mentions that Ashwins are the earliest deliverers of light. The shlokas also mention that the twins protect the sun from getting eclipsed. Now, this uh, someone might try to interpret why is it that in the Rigvedic hymn, this has been mentioned that the Ashwin twins, they protect the sun from getting eclipsed. The shlokas also mention that uh, Ashwins apparently saved some of the Vedic persons like Reva, Vandana, Atri. We know Atri being one of the writers of the Rigvedic shlokas. Kanva is also a famous rishi in our historical, in the mythological scripts, as well as Antaka from deep pits. Now, this shloka, of course, would create a lot of curiosity in the readers. Why would these people fall into the deep pits, and why would they say that it is the Ashwins who saved Reva, Vandana, Atri, Kanva, and Antaka? So people may speculate that the Indus Valley people, when they were leaving their cities because of unknown reasons like drying up of the Sindhu River, or famine, or disease, or some natural calamities like earthquake which disrupted their dam system. There are a lot of historical speculation as to why Indus Valley declined. But Indus Valley, you can, if you look at some of the excavation sites, there are a lot of wells and deep pits. For example, the Great Bath of Mohenjo-daro itself is a deep well kind of a structure, and probably the wandering Rigvedic uh, uh, Indo-Aryans, they would at times fall into these pits when it was dark. And the shloka that Ashwin saved them, probably when before the sun rose, when they spotted the beta and gamma Arietis, the hopes were sort of they burgeoned in their heart, and that they would essentially come out of the deep pits. Of course, these are matter of speculations. There is another shloka. Anyone who wants to see this particular hymn can go to Griffith's translated volume of the Rigveda. Griffith, who published his translation in 1896. It is available in the internet. Please go through the shloka. You'll find that there is a very curious shloka where it is mentioned that Bhujyu was rescued by Ashwins from the ocean when he was abandoned by Tugra. Some scholars think that Tugra was a fatherly person of Bhujyu, and due to some reason Bhujyu got abandoned in the middle of the ocean. And apparently, Ashwins rescued Bhujyu, and it is said that thousand armed object came and rescued Bhujyu. One can only interpret that probably a ship with many oars finally rescued Bhujyu, and maybe the ship used the Ashwins to navigate and locate Bhujyu. Anyway, these are matters of speculation. We cannot be sure as to whether that was indeed the sequence of events. But these are interesting speculation concerning the antiquity of astronomy in the Vedic text. The beta and gamma Arietis, of course, they are referred also in Greek and Roman epics as Castor and Pollux, or sometimes as Dioscuri. In Indian context, the twins Castor and Pollux, they are also referred to as Punarvasu. And often, some of the Indian scholars of mythology, they think that uh, the Vasu descendants like Lord Krishna and Lord Valarama, they probably originated essentially from the Punarvasu, the twins. And in the Greek and Roman epics also, the Castor and Pollux, they are patrons to the sailors, just like Ashwins are often referred in the context of um, uh, of deities who rescued people from ocean. Similarly, in the Greek and Roman epics too, Castor and Pollux, they are patron deities to sailors. So clearly, the fact that they were used by sailors for navigation purposes is very evident from the Greek and Roman literature. And they were also skilled horsemen, even in Rigveda. Rigveda also mentions that Ashwins apparently were great um, uh, horsemen. In fact, Mahabharata, in which Nakul and Sahadev they were twins. They were supposed to have been sons of the twins Ashwins. If you have read Mahabharata, you might know that Nakul and Sahadev are supposed to be expert horsemen and trainer of horses. So there is a similarity. And of course, this is not surprising because the entire Indo European language. There is a similarity in the language, and not only that, some of the mythologies also are similar. And these are the reasons why historians believe that the Vedic people and the Europeans, they share a common ancestry. Right. Castor and Pollux also have been depicted uh, in this marble relief, as you can see, the uh, the horsemen, a pair of horsemen, and there is a marble relief uh, from 200 BC, and right now this uh, marble relief lies in Louvre Museum in Paris. Right. Uh, so let's look at a little bit more on the astronomical context in Rigveda. In previous lecture, I had already mentioned that Rigveda mentions a shloka due to the seer Atri or the family members of Atri, because sometimes in the Indian tradition, the the most senior ancestor's name is often taken, although the work might be of his descendants. So, we have already mentioned that Atri Shloka says that Saurabhanu, a demon, pierces Surya with his arrows and causes darkness, and it is one of the early depiction of eclipse in Indo-European literature. But the Satapatha Brahmana, it is a text that accompanies Rigveda. In Satapatha Brahmana, there is a shloka which again I had referred to in my previous literature, in which uh, the Yajna fire to be lit when Kritika Nakshatra is rising in the east during the spring equinox. But as I mentioned in my previous lecture, in current times, during the vernal equinox, the constellation that rises in the east is not Pleiades, but it is Aries. And only when you do a calculation taking into account Earth's precession, only when you go to 2334 BC, you find that Kritika would have been rising in the east during the spring equinox. So, therefore, this shloka must have, that has been explained in Satapatha Brahmana, must have been written around 2334 BC. And in fact, that Kritika Nakshatra rose during the vernal equinox is also recorded in a Chinese text, which has been also dated to 2334 BC. So, astronomy indeed presents us with a chronological assignment of this particular shloka. You might ask, when did our Siddhantic astronomers, I will soon mention what is a Siddhantic astronomy, but astronomers like Aryabhatta, Brahmagupta, Varahamira, Bhaskara, uh, these astronomers, they are referred to as Siddhantic astronomers. And it is certain that by the time of Bhaskara I, the Siddhantic astronomers already are stating the precession of the equinoxes. That means the fact that the axis of the earth, due to the tidal forces of the moon, precesses around the direction which is normal to the Earth Sun orbital plane, the precession of equinoxes are already known and they are already written in the text by the time of Bhaskara I. But there is also evidence, indirect evidence, that probably Aryabhatta himself had deduced the precession of equinoxes. I'll come to that. Yeah. So one of the very important text concerning the Siddhantic astronomy and in particular sciences in Vedic India is due to David Pingree, written in 1972. Those who are interested in this particular topic, mathematics and astronomy in Vedic India, they can refer to this paper of David Pingree published in 1972. And David Pingree mentions that the Greek or the Hellenistic astronomy had already started influencing the astronomers like Aryabhatta, etc. For example, uh, Hipparchus, I already mentioned that Hipparchus, who was around 175 BC, and he was one of the first to have sort of discovered the true reason for solar and lunar eclipse. And David Pingree cites that Spuji Dhwaja, who was a Siddhantic astronomer, he already in his text Yavana Jataka uses Hipparchus' length of the tropical year. Now note the uh, word Yavana Jataka. Now Yavana in Sanskrit literature refer to the Ionians, the Greeks, the Hellenistic people, who were also referred to as Ionians. Ionians in Sanskrit became Yavana. So it is often conjectured that Sfujidhwaja could have been Greek in origin. Is Yavana Jataka, which was written in 269 AD, uh, uh, already refers to the work of Hipparchus. Varahamihira, Varahamihira's text in written in 550 AD also discusses this aspect. Now, I mentioned that Aryabhatta, who was very active around 474 AD, that Aryabhatta could have also realized about precession of equinox. The evidence comes from Govind Swamin, another Siddhantic astronomer. Govind Swamin in 1850, he refers to a work of an astronomer Manindha, and apparently Manindha stated that Aryabhatta 1, that is the Aryabhatta of 474 AD, Aryabhatta 1 already had mentioned that the vernal equinox, uh, during the vernal equinox, it is Aries that rises in the sky. And probably the fact that Aryabhatta also knew that Satapatha Brahmana mentions that is a Kritika nakshatra that rises in the east during the vernal equinox, Aryabhatta must have realized about the equinox. But these are conjectures. What we know for sure is by Bhaskara 1 already the precession of equinox was already known to our Siddhantic astronomers. So, what are the Siddhantic astronomy texts? I mean, what is Siddhantic astronomy? So, these Siddhantas were composed from about 500 BC to 1900 AD, a long span of time. And Siddhantas are nothing but Sanskrit treatises on mathematics and astronomy, which are composed in poetical style. Probably that was the tradition in the earlier times for the purpose of remembering, as those days there were no papers and most of the uh, compositions or deductions were orally transmitted. And for oral transmission, poetical form was necessary because one could immediately verify whether someone has memorized the Siddhantas by looking at the poetry, the text, and the details of the poetry. So we already know that Aryabhatta, the first Aryabhatta, he had already completed his Aryabhatiya, which is one of the Siddhantic texts, by 499 AD, and it is one of the grand uh, Siddhantic texts because Aryabhatta, as I have mentioned before, every astronomer all over the world, they uh, acknowledge the genius of Aryabhatta because not only he had realized the real reason for the solar and lunar eclipses that I had already described in my previous lectures, but he already had realized that it is Earth which is spinning about its axis. In fact, not only that, it is speculated that he already had sort of got a hint that there is some force due to Earth which keeps the objects on the surface of the Earth attracted. How do we know that? Because when he spoke of rotation of Earth about an axis, critics, they sort of poo-pooed the idea, saying that it can't be correct, as anything that rotates, so throw away objects on it. Just like when we are in a merry-go-round, we have to hold on to the railings of the merry-go-round. If we don't, if the merry-go-round is rotating, then we'll be thrown away from the merry-go-round because of the so-called pseudo force called centrifugal force. So when the naysayers said that Aryabhatta's thesis that Earth is rotating cannot be true because we are not being thrown out of Earth, Aryabhatta supposedly answered that we are not being thrown out because there is an attractive force due to Earth that sort of keeps us from flying away from this rotating Earth. This has been described in the Nobel laureate Amartya Sen's book in The Argumentative Indians. Do please go through this part in The Argumentative Indian, authored by the Nobel laureate Amartya Sen, who himself is a great scholar of Sanskrit texts, and he has studied several Sanskrit philosophical schools like Nyaya, Samkhya, etc. Varhamira, in his Panchasiddhantaka, of course, he makes a very clear statement of the cause and effect regarding the events of solar and lunar eclipses. There is then a very old Siddhant called Surya Sadhana that has been compiled from 300 BC to about 1000 AD. No one knows who was the initial uh, scholar who started the Surya Siddhanta. It is attributed to a mythical figure called Maya Asur. As you know, Maya Asur also comes in Mahabharata, who was supposed to have created the Indraprastha palace, the magical palace, or the palace filled with illusions, that finds mention in Mahabharata, and Mayasura or Maya Danav created this Indraprastha at the behest of Lord Krishna for Pandavas. And the same Maya Asura, of course, these are essentially conjectures. Same Maya Asura was supposed to have started the work on Surya Siddhanta. Then we have the Siddhanta Bhashvati, which was composed by Satananda around 1099 AD. And the last Siddhanta, then there were several others in the Kerala school of astronomy and mathematics. The last Siddhanta, I think, is the Siddhanta Darpana, which was written by a great astronomer, Patani Samanta Chandrasekhara, who completed the Siddhanta Darpana in 1869. Both Satananda and Patani Samanta Chandrasekhar, they belonged to the state of Orissa. Of course, in 1099 AD, that state was referred to as Kalinga. Now, again, you might wonder that why was astronomy being so popular in these two states as well as in the southern states? And that's the reason why Kerala school plays such a famous school concerning mathematics and Siddhantic astronomy. And one of the reason could be the navigation that was required by the sailors. For example, we know Kalinga of ancient times, the present day Orissa, they were a very seafaring state. There is a very famous festival of Orissa called Bali Jatra. The Bali Jatra, as the name itself suggests, that in the month of Kartik, again, which is related to Kritika Nakshatra, sailors from Kalinga used to sail towards the Bali island. In fact, the old text of these far southeast regions mention the Kalinga sailors as klings. And even before the custom of Bali Yatra, the caves of Udaygiri and Khandagiri, which are just at the outskirts of the city of Bhubaneswar in Orissa, there are caves, and they are dated to period older than 1st century BC, because there is a slab in the region of Udaygiri Khandagiri in which Kharaveda, who was a king of this region, his edicts are sort of engraved in this 1st century BC slab at the site of Udaygiri Khandagiri. And in particular, the Ananta Gumpha. Gumpha is the Odia word for cave. So there is a cave called Ananta Gumpha, and it has a sculpture of sun god on a chariot drawn by 4 horses along with crescent moon and stars. And furthermore, in the writings of Kharaveda, Kharaveda has claimed to have conquered a place called Pitunda, which is a port. So again, it highlights the importance of astronomy and navigation. And as I mentioned, Kalinga, in fact, had a whole culture of navigation. And sometimes historians say that that many of the tall temples like Puri Jagannath temple as well as Konark temple, both are located at the beach, very close to the beach, corresponding to the Bay of Bengal Ocean. And often historians say that these temples were used as a landmark by sailors when they would try to figure out whether they are close to the port. A tall structure can be seen from the distant horizon. So the temples of Lord Jagannath and the Konark temple, they served as some kind of beacons for the sailors. And there are many known ports in Kalinga, namely Palur, Konarak, Chilika, and Tamralipti, which is now in the state of Bengal, which is also referred to as Tamluk. And Sun Temple, of course, highlights it's one of the uh, grand temples in which the chief deity is a cosmic object, namely Surya or the sun. And here the sun god has been depicted wearing boots. Probably the artists were familiar with Brihat Samhita of Varahamira. Varahamira depicted Varahamira, his culture, he was supposed to have been a Maga Brahmana who wore boots. And the fact that the sun god was depicted wearing boots, historians say that probably the artists were inspired by Varhamira's Brihat Samhita. And here is a slide depicting the top left panel are the caves of Udaygiri and Khandagiri, presently a very famous Jaina pilgrimage site, because there is also a place where Varadhavan Mahavira's huge idol is established. And here is the Surya god depicted. And now, of course, the leg portion has undergone a lot of erosion because the pilgrims would come and touch the feet. So you can't make out the tall boots, just an inkling you can have. So pilgrims, since several hundred years, would come and touch the feet, and that over several years had caused erosion. As you can see, the top part doesn't look as polished as the bottom part. Now, of course, if you go to Konark, you're not allowed to touch any of the idols of the sun god. And here is the Natya Mandir portion of the Konark that survives. The main, the so-called Vimana portion of the temple doesn't exist anymore. It is in ruins, the tall structure. And there is also a story associated with it. Anyway, that's a separate aspect. One need not go here. And this is also another panel that describes the sailing culture of the Kalinga state. As you can see, that you have a magnificent big boat with proper shelter for the rich person who could afford such boats. Now, the structure again reminds one of the Indus Valley boats that we saw present in the amulet as well as in the Indus Valley seal. As I mentioned, that apart from Patani, Samant Chandrasekhar, Satanand was the only other well-known Siddhantic scholar, and it is known that he lived in Purushottampur, which is the modern-day Puri, and he composed Bhashwati, the Siddhantic text, around 1099 AD. And here, Satanand in his Bhashwati mentions clearly that the Aries constellation indeed rises during the spring equinox at the east, and he in fact deduced the precession at the rate of 1 degree in 60 years. Of course, that is a um, sort of gross estimate. So Satanand indeed deduced the precession of the equinox, and his figure was 1 degree in 60 years. This has been cited in David Pingree's research paper published in 1972. Right. Of course, the one of the most famous Siddhantic astronomer is Patani Chandrasekhar Samanta. As you can see, there was also a postage stamp released paying tribute to Patani Samant Chandrasekhar. And his work, which was in Sanskrit, and it was composed in 1869, and it was translated by Jogesh Chandra Rai in 1898, because Jogesh Chandra Rai realized how important the text is, and he sent it to Nature, and Nature journal went through the translated version and was in full praise of Patani Chandrasekhar Samantha. And there is one particular line I would like to uh, draw your attention to. It's a Sanskrit line which states that Pratyaksha Anubhavam Na Lampati Vacho Yuktir Yataha, whose translation is that arguments can never defeat the results of direct observation. Now, I would say that this is one of the very profound statement concerning science. Let me repeat again. Arguments can never defeat the results of direct observation. In fact, Patani Samant Chandrasekhar, he was a impoverished scholar. He did not have any source to sort of obtain the Western telescopes so readily available those years, but he made his own observation tools using bamboo rods, etc. And he did naked eye observation and came to wonderful conclusion. And no wonder he realized that theoretical arguments are no substitute for direct observation. We know in science that, after all, science is an empirical study of nature. That is, all our theoretical models, observational and measured data. And this is one of the statement that an impoverished scholar like Patani Samant Chandrasekhar had realized all by himself. And in fact, through his naked eye observation, Patani Samant Chandrasekhar gave a model of the solar system. What was his model? His model was that sun, here is a slide of his model depicting his model of the solar system. According to his model, sun went around Earth. Of course, moon also went around Earth. But all the rest of the planets, whether it is Mars or Mangal, whether it is Jupiter or Brihaspati, whether it's Saturn or Shani, they all went around the sun. That means what? Except moon and the sun, rest of the planets went around sun, while sun itself went around the earth. This model was very similar to Tycho Brahe's model of the solar system. Tycho Brahe had also uh, essentially made such a model of the solar system. Remember that Chandrasekhar based his model through naked eye observation of the planetary positions and the positions of moon and sun. In fact, the Nature article that praised uh, Patani Samant Chandrasekhar work, in fact, compares Patani Samant Chandrasekhar with Tycho Brahe. And we already know Tycho Brahe's superb observation that led Kepler to develop the laws of planetary motion. We have already encountered it in our previous lectures. Uh, okay. Probably there are some questions. Um, are there any questions? Okay, there are some questions. So let me answer the questions one by one. I see that there is a question by Shivangi Puri. She writes, this probably is regarding the Olbers paradox. She says that we made a relaxation to the second assumption, and so light from all the stars has not yet reached. So, in the times to come, will the night sky be not this dark? Good question. Uh, so, as time goes on, the observable part of the universe that keeps increasing, no doubt. And therefore, as time goes on, the background sky will become marginally brighter, but the time scale, remember the time scale involved in such brightening is a billion years, because the rate at which universe expanding, and therefore the rate at which the observable part of the universe, which is called the Hubble radius, that is expanding at a very slow rate. So only on scales of billion years one would be perceptible to the change in the background radiation. But of course, one must also realize that there is also redshifting. Universe is also expanding, and hence the high frequency lights get redshifted to low redshift, and that impacts the amount of energy that is received per unit time, per unit area. So, to answer finally your question, that yes, the background sky will be marginally brighten, but at a very, very slow rate, because the time scales of expansions are extremely large. And furthermore, we have to also factor in the expansion of the universe, and particularly, we know today that the expanding universe is expanding at a rate that is increasing with time, so called the late time acceleration of the universe. So, the radiation, in fact, would be getting redshifted also. Right, yes. There's a comment by Priyamvada which says Rakhi Gadi in Haryana is the oldest site. Yes, and lot of our Indian archaeologists are actively researching in the Rakhi Gadi area of Haryana, and lot of genetic studies on the remains of uh, Indus Valley people are also being made regarding Rakhi Gadi, Kalibangan. etc. And yes, the archaeology associated with the Indus Valley civilization is a very, very exciting area of historical research. Right. Shubham Gangavar says, why, due to the expansion of the universe, the polar star, namely Dhruvatara, is not disappearing? Yeah, this is a question which has to be thought about a little bit deeply. So let me slowly mention what are the subtle issues very often that is overlooked by a new reader of cosmology. When we say that universe is expanding, what are the units that are moving apart from each other as the universe is growing old? The correct answer is it is the galaxies, namely the field galaxies, not the galaxies which are bound to the rich clusters of galaxies, but it is the isolated galaxies that are moving away from each other. I must also make a very categorical statement here. It is not that the galaxies are traveling, rather, the Hubble redshift versus distance say, if you correctly interpret using general theory of relativity, that the Hubble expansion mentions what it reflects is it's a distance between the field galaxies and between galaxies and clusters of galaxies. It is the distance between these units that is increasing with time. It's not that isolated galaxies are in an ordered fashion traveling away from each other. That is not true. What is true, that comes from the study of general relativity and modern relativistic cosmology. It is the distance between the galaxies that is increasing with time. If that is the case, obviously the objects within our galaxies, they are not moving away from each other, because the objects within our galaxies are in a gravitationally bound system. As you know, our galaxy is made out of a huge dark matter halo, and within the dark matter halo, there are these stars which are going around, and our solar system is also going around the common center of our Milky Way galaxy. We will come to galaxies shortly, most probably in today's lecture itself. So, the stars in our galaxy, they are not moving away from each other. The expansion of the universe doesn't mean that we are expanding or Earth is expanding or stars are going away from each other. We are a gravitationally bound system. The expansion of the universe happen only at a scale of 1500 million light years. Okay, so this scale must be remembered. Only on scales of 1500 million light years that the universe expands. Scales which are smaller than these, where systems are bound gravitationally, they don't expand. And hence, polar star is not moving away from each other, and therefore it doesn't uh, disappear. There's another question from Shivangi. The Sun Temple, Konark, have been built over a ratha and wheels, tells us the current time. How would have? Well, Shivangi, the reason why the Sun Temple is built like a chariot which is on wheels is because of the mythology that sun god moves on a chariot that is drawn by seven horses. And in fact, there are horses, stone horses carved out in the premises of Konark. Okay. And it is based on mythology that the sculptors built the Konark temple. It is not true that the Konark wheels can be actually used as a sundial, although some archaeoastronomers mention that the wheels can act as a sundial, but that is not true because the wheels are all around, not just at the eastern part of the Konark temple or the western part of the Konark temple. So, in short, to answer your question, the Sun Temple being depicted as a chariot on wheels drawn by horses comes from the mythological aspect of how Sun has been depicted, drawn by uh, the seven horses, representing the seven colors of the rainbow. All right. All right, so now let's continue with the lecture if there are no more questions. By the way, uh, we will soon be doing simple calculations concerning astronomical objects. At the moment, we are uh, in the unit one, which is to do with historical aspects of astronomy. So, as I had sent in my email, students must read the book by Frank Shu uh, that bears the title The Physical Universe. It's a delightful book with very simple problems scattered all over, and these problems can be done using simple arithmetic. So, all of you who are crediting this course must go through the Physical Universe by Frank Shu and also do the simple numerical problems which are sort of given all through the text and the chapters. Right, so let's continue with our lecture. So, as I mentioned, the stars were not only sort of mysterious with their twinkling and making the night sky so very interesting, as though there are these bright diamonds scattered all over the velvety night sky. But stars were also used by our uh, ancestors, in particular, for deciphering the directions, and commonly by the sailors when they were navigating. Stars formed very important objects to give a sense of direction. In particular, the Dhruvatara or the pole star was very important as its direction was fixed when the Earth, as the Earth went about its natural spin around its own axis. So, in the course of time, all stars would rotate around Polaris, including the Saptarishi. Here, lines have been joined, but the Saptarishi stars are 1, 2, 3, 4, 5, 6, 7. And there is also, with Vashishta, there's a faint star called Arundhati star. Now, anyone who has seen a clear night sky, if you want to locate the Dhruvatara, the best thing is to first locate the Saptarishi. Saptarishi can be easily sort of located. In Western literature, The shape of the Saptarishi is likened to a wagon. So it's like a wagon. In Indian context, it is also likened with a plow or a hull. Now, if you want to locate Polaris, what you have to do is take the head part of the Saptarishi, the first two star, and go almost straight line. Okay, if you go almost straight line, then five times this side AB gives you the position of the Dhruvatara. All right, good. So we know that stars certainly played a very important role. And by the way, I again reiterate, I asked you a question that uh, our ancestors could immediately make out the difference between stars and planets by two simple techniques. One is that stars twinkle while planets don't, while the other fact is that with respect to the stars, planetary positions change, while the stars, the relative position of stars do not change. Of course, in reality, stars also relative position change because they are also going around the common center of our galaxy, but the time scales are million years, more than million years. So therefore, within the span of human civilization, the positions of the stars have not changed appreciably. And I asked another question. Please try to find out. I am curious to know whether in Sanskrit texts or in old Indian text, the fact that the stars twinkle but the planets don't, are they mentioned? Right. Natural question from here is that, well, planets we can figure out because we know Earth is a planet and we know the nature of Earth. So maybe Mars is a planet similar to Earth. Moon also appears to be solid, and so on. But what are stars really like? So for a long time, no one knew that stars are much, much more massive than planets. In fact, as you know, in our mythology, stars were supposed to have been very light objects. In fact, a late shloka of Rigveda, a very late shloka of Rigveda states that stars are held by light banyan tree like roots and maintained in the sky by the god Varuna. Okay? And also in our mythology, we know that the so called Ulka or a meteor is said to be a star that falls down from the sky. So, stars, it was not realized that the stars were much, much more massive object than planets. So, what are really stars and how are they formed? So, here this slide gives a qualitative uh, explanation. Again, this slide, the credit is faint, but here is the credit. The credit is to Mac Goharamian. And remember, every slide must be credited if one has not created the slide. The modern way of looking at formation of star is as follows. First of all, there are these giant molecular clouds that are present in galaxies. These giant molecular clouds, they weigh million times heavier than sun, and they are very cold bodies of gaseous matter. Predominantly, of course, hydrogen and helium are there, but trace elements of molecules like ammonia, methane, etc. are there. And these clouds, they also cool by radiating. The transition, molecular transition help in cooling the gas cloud. And as these gas clouds cool, they start shrinking. And then there is an instability called Jeans instability. Uh, later on, I'll give you simple way to understand gene sensitivity and simple numerical way to calculate uh, when genes instability will happen. We will do that when we become a little more familiar with the basic concepts involved in astronomy and astrophysics. So, when a giant molecular cloud starts shrinking, different parts they undergo instability and start collapsing, and a fragment of a giant molecular cloud would start collapsing, and this collapsing cloud, as it collapses, it becomes hotter and hotter. Why does it become hotter? Why does a gas cloud, when it collapses, start becoming hotter? It can be understood from simple ideas of gas thermodynamics that we have learned from our school days. We all know about Charles' law, Boyle's law, and so on. We know that if you take a jar of gas, that on the top part, if you have a piston with a weight so that the jar of gas is not expanding to begin with, now if you compress, start pushing the piston downwards so that the gas gets compressed, we all know that the gas gets heated up. Why? Because by pushing it, we are doing work on it. And by doing work, the internal energy of the gas increases. And internal energy increasing, meaning the temperature also rises. A cloud collapsing under its own weight, the volume is again decreasing, and it is therefore undergoing compression, where as the volume decreases, the pressure goes up. If the pressure goes up, the temperature also goes up. So remember that the gas cloud to begin with can also be rotating. As in the previous lectures, we discussed how the original spin could have happened due to tidal torquing. So the original gas fragmenting gas cloud could have been also rotating. So as it shrinks, the part that were rotating will start rotating even faster. Angular speed will increase because the total angular momentum is conserved, and angular momentum is moment of inertia into angular speed. So when something is shrinking, moment of inertia decreases, and because angular momentum is conserved, angular speed must go up. If the angular speed goes up, the centrifugal force goes up, because centrifugal force goes as mass times square of the angular speed times radius. So those portions which are rotating, they will keep rotating very fast, and the centrifugal force will make them, the parts that were rotating will make, they will acquire a disc like shape, while the portion that was not rotating so fast would contract in a spherical manner, and the centrifugal force for the rotating part will not like the disk to contract, because there is a centrifugal force balancing the inward gravitational force, while the region which is not rotating so fast, the centrifugal force will not be that powerful, and gravity will win and will contract. And as it contracts, it becomes hotter and hotter and hotter. And when the center of such a contracting uh, gas cloud reaches a temperature of few million degrees Kelvin, That means 1 followed by 6 zeros, more than 1 followed by 60 degree Kelvin, then at the center, protons can, as they are whizzing by each other due to random motion, the temperature is very high, and the temperature has crossed the million degree Kelvin regime. So when it's about 10 million degrees Kelvin, the randomly moving protons, they can overcome their Coulombic repulsion and they can come so close that quantum tunneling would make the protons undergo nuclear fusion. And this nuclear fusion, in which effectively 4 protons would combine to form one helium nucleus emitting high energy photons and neutrinos. So the energy of photons and neutrinos are roughly few million electron volts of energy. As you know, 1 electron volt is equivalent to 1.6 into 10 raised to the minus 12 erg. So roughly few times 10 raised to the minus 6 erg is released when every 4 protons effectively fuse under thermonuclear fusion to give rise to one helium nucleus. This much of energy is released, and it is this energy that makes the star so hot that the pressure generated by heat overcomes the gravitational uh, collapse, and the star becomes stable against gravity. While the disk, which is maintained by the centrifugal force, the disk cools and slowly the gaseous part evaporate away, but the solid part made out of different molecules like uh, silicon, silicates, uh, carbon-based molecules, etc., they form a dust-like disk, and slowly parts of the dust-like disk condense and they give rise to solid planets. Of course, there'll be gaseous large planets like Saturn and Jupiter. This is roughly a pictorial way of describing how the solar system is formed. And as we discussed in the previous lecture, one of the main evidence that such a formation scenario is correct is that the sense of rotation, all the planets of our solar system are rotating in the same direction, just like the differential rotation that we observe on the surface of the sun. The sense of rotation is in the same direction. And roughly speaking, the sense of rotation of the spin rotation of individual planets are also roughly in the same direction, barring the tilt. There is, of course, one planet whose tilt is almost along the plane of the orbit, sun planet orbit. But barring such exception, not only the orbital angular momentum, the spin angular momentum is also roughly aligned with the differential rotation of the sun, stating that the scenario in which a single rotating cloud collapsed to give rise to our solar system. Let us also look a little bit at the detail of how due to the enormous heat that is generated at the core of a star, example being sun, uh, how the thermonuclear fusion, whereby the randomly moving protons they fuse, aided by the quantum tunneling by which the nuclear force starts causing effectively four protons to a single helium nucleus, and the resulting energy generated. Why is energy generated? You can do a simple calculation that if you take a helium nucleus and its mass multiplied by c square, we all know from Einstein's special relativity, anything that has mass m has energy mc square, and anything that has energy E has mass E divided by c square. That is what we mean from the derivation that follows from Einstein's special relativity. And therefore, if you take a helium nucleus and multiply by c square, that is the rest energy of the helium nucleus. Now, what at, on the side, you can do another calculation. Take proton mass, multiply by c square, that is the rest energy of a proton. And we said that four protons under nuclear fusion, they fuse to become one helium nucleus and releasing photons and neutrinos. So therefore, multiply the rest energy of the proton by 4 to include 4 protons rest energy, and lo and behold, you will find that the rest energy corresponding to 4 protons is slightly greater than the rest energy of a helium nucleus. But the total energy has to be conserved. So you subtract the 4 protons rest energy, from it you subtract the helium's rest energy, and you will find that this energy is of the order of 3 to 4 MeV, that means 3 to 4 million electron volts, and it is this energy which is carried away by the photons and neutrinos and cause the core of a star like sun to be extremely hot. And of course, the heat gradually, by means of radiation, conduction, and convection, they get transmitted outwards and maintaining a temperature and a pressure gradient. That means the core region will be very hot, but as you go outwards, the temperature will keep falling. This is exactly like when you are heating a pot of water in your stove, then you know that the stove where gas stove where the flames are coming out, that is a source of energy, and that portion of course is much hotter than the when you are initially started heating the pot of water. The flame is much hotter than the surface of the water before the convection starts. There's a temperature gradient. Of course, when the convection begins, then of course, when the water starts boiling and the convection begins, then of course, the hot water rises up because of being low dense portions. And then, of course, the temperature gradient somewhat goes down. But in a star like sun, for a till you come to the convection zone, the temperature gradient monotonically, the temperature monotonically decreases till the convection zone is reached. And it is the temperature gradient which results in the pressure gradient. That means what? That pressure near the center is much higher than the pressure as you go outwards. It is this which results in a hydrostatic equilibrium by which the the tendency to collapse due to gravity is checked by the pressure forces. To give a slightly more microscopic description, again, remember this slide, the copyright is by Pearson Prentice Hall. There's not a slide which was made by me, so one must give credit to that. So, in other words, in a star, there are two opposing processes that are taking place. Gravity is trying to make the matter of the star contract, while the pressure gradient opposes this gravitational contraction. So, as Frank Shu writes in his book, that most processes in astrophysics results out of a competition between laws of thermodynamics and laws of gravity. Of course, laws of thermodynamics have to take into account many microscopic processes where all other laws of physics start appearing. Right. So remember, it is the pressure gradient which gives rise to the balancing of gravity versus pressure. And there's a microscopic description of uh, what is pressure and temperature from kinetic theory of gases. We know that if you take a box filled with gas, uh, we know that when you are having the gas at a lower temperature, then the average kinetic energy of the gaseous atoms or molecules, average kinetic energy is lower. They are randomly moving, but the random kinetic energy when the temperature is lower, random kinetic energy is smaller. Unlike the case when the gas is hotter, when it is hot, then the average kinetic energy of the atoms or the molecules making up the gas is more. Pressure is essentially related to number density of gas times the average kinetic energy of the gas. And therefore, if the average kinetic energy is larger, pressure is also larger. In other words, if the temperature is larger for uh, most of the gaseous system which are close to ideal gas, then if the temperature is large, pressure is also large. And hence, in a star, when the core is hotter, pressure is also very hot. And therefore, if you have a pressure gradient, so imagine a thin slice of a gaseous system where there is a pressure gradient. That means out here the pressure is higher than the top portion of the pressure. Then you can see how hydrostatic equilibrium happens. So if you take a slice of the solar material, and we know that towards the center, temperature and the pressure is higher compared to outwards from the center, then we find that the weight of this solar slab, weight due to the gravitational attraction, can be balanced if the difference between the force arising due to lower pressure and the force arising due to the upper pressure. Remember, Pascal's law says that the pressure is exerted in all direction. So if you take a point, all the points on the lower part of the solar slab, the pressure on the points on the lower portion, they are all acting upwards. Okay, where the pressure acts is in all direction, but the lower points, therefore, due to the ambient solar plasma, the pressure is acting upwards. While if you take the top surface of the slab, again here the gaseous matter pressure is being exerted in all direction. After all, the gaseous atoms or molecules, they are moving randomly in all directions. So the pressure is being exerted in all direction. However, on the points on the top surface of the slab, the pressure is acting downwards. So, if the pressure acting upwards is larger than the pressure acting downwards by an amount which is such that the area times pressure is a force, and therefore, if this resultant upward force is equal to the weight of the slab due to the gravitational pull acting downwards, then there'll be a hydrostatic equilibrium. And that is the reason why the temperature and the pressure gradient in a star, it maintains a star in an equilibrium configuration. The star doesn't shrink in appreciable time. Okay. Here I must tell you one historical note. Before the idea of thermonuclear fusion causing stars to not only shine but remain in thermal equilibrium, people in the late 19th century and beginning of 20th century, people like Lord Kelvin, they thought that a star is hot and thereby it radiates. A star is hot because the gas which is making up the star is contracting gravitationally, and because it is contracting gravitationally and getting compressed, all right, therefore is getting heated, and it is this heat energy which makes a star hot. In other words, Lord Kelvin, Lord Kelvin was suggesting that the energy of stars comes out due to the gravity being attracted. So as the star shrinks, gravitational potential energy becomes more negative, and because of conservation of energy, if gravitational potential energy is becoming more and more negative, rest of the energy must be released as the heat, because to begin with, the star had more energy, it had less negative gravitational potential energy. But immediately from calculation, it could be shown that if Kelvin's model is correct, then one can figure out from the sun's luminosity. I had mentioned earlier, sun's luminosity is of the order of 4 times 10 to the power 33 ergs per second. That means every second, sun is releasing energy of the order of 4 followed by 33 zeros erg. It's a huge amount of energy. But the energy is being released isotropical. Only a fraction of this energy is intercepted by the surface of the earth. And that is what gives rise to the daytime temperature of earth. Hence, from the solar luminosity, if you calculate the fact that sun is losing such a high energy per unit rate, therefore it must be also shrinking, so that gravitational potential energy must be decreasing also at the same rate. If you do a simple calculation, you can show that sun will shrink to a point in few million years time. In other words, if Kelvin's model, if Kelvin's model for solar radiation is correct, namely sun is radiating because its gravitational potential energy is becoming more and more negative as it shrinks. If it is correct, then sun can last only for a few million years. But from studies of radioactive dating of Earth, or Earth itself is more than billion years old. So clearly, Kelvin's model cannot be correct. So gravitational potential energy becoming more and more negative cannot be the cause of solar radiation. Only after the works of Eddington, it was realized that it is the nuclear fusion which could be the cause of solar radiation. And later on, of course, a lot of thorough calculation by Hans Bethe explained unequivocally that indeed the stars radiate because of the thermonuclear fusion. And in astrophysics, all the stars which are shining due to effectively four protons going to one helium nucleus, such stars are called the main sequence stars. Again, let me repeat. The main sequence stars are defined to be those stars in which the source of energy is the four protons effectively going into one helium nucleus. There are other stars like red giant, okay, blue giant, supergiant, and so on, where the source of energy is thermonuclear fusion, but the core fusion that is going on is not proton proton fusing to helium. It could be uh, helium fusing with the other helium to form carbon, carbon fusing with helium to give rise to nitrogen, and so on. There are all kinds of complicated sequences that gives rise to other variety of stars. But the main sequence stars are those stars in which the core uh, undergoes a thermonuclear fusion where four protons fuse to become one helium nucleus. So as I said, here is the sequence. In the main sequence star, the core in which hydrogen goes to helium, the rest of the envelope is heated up by the energy released from the core due to protons going to helium. In the post main sequence stars, you have helium burning in the core. In the red giant star, you have helium going to carbon, then carbon going to nitrogen. And but in the red giant star, what happens is the envelope, because when the core becomes carbon, nitrogen, oxygen rich, the thermonuclear fission gets halted because these are highly ionized nuclei, and to fuse you would require higher temperature. So therefore the envelope immediately surrounding the core, it starts contracting as it cools, but as it starts contracting, it becomes heated up and the shell starts burning, and the burning of the shell, hydrogen shell, makes the outer envelope expand and the red giant expands. Why does the outer envelope expand? Because the outer envelope, there the gravitational acceleration is lower. So when the hydrogen shell starts burning, the radiation pressure is more than the gravitational attraction on the shell as the shell lies outwards. So it expands, and a red giant star becomes huge. And calculations show that after few billion years time, our sun itself will turn into a red giant and will become a huge bloated star. And as it expands, it'll cool down, and that's the reason why the surface, as it cools down, will appear redder. And the size of the bloated red giant star would be so large that it will swallow even Mars. That means it will swallow Earth, of course. If it reaches Mars, it will, of course, cross Earth. So, indeed, Earth will no longer exist when our sun becomes a red giant star. But we don't have to worry. Billion years are still there for us to enjoy. We right now have to only take care of COVID-19. We don't have to bother about the sun turning into a red giant as of now. After billion years, then human beings will not be of the same form as of now. With science, technology, computers, we will turn ourselves into tiny robots, our memories being uh, sort of downloaded into tiny, tiny computers, and these tiny robots would fly away to distant planets. So the future will be very, very different. And the study of science helps us in indeed imagining or guesstimating what kind of a future we'll have after millions of years. I will stop as I see that I've already overshot the time limit. I will stop here. Let me mention today we will meet. Our afternoon lecture will be at 5 o'clock. If it is all right with you, our afternoon lecture will be at 5 o'clock. I will stop for now, but I will take questions. Any questions that you have, I will take now. Okay, I'll go in sequence. Shivangi Puri says, yes, so about stars twinkling and planets not twinkling. Right. Yeah, it is very strange that our ancient literature doesn't refer to twinkling of stars, but I have a speculation of my own. Remember, in our old texts, we say that Dhruva, he was meditating so hard uh, because his mother and he was not the preferred wife and son of um, uh, the king, and therefore to answer the question why and to sort of get solace, mental solace, he went into a deep meditation and eventually he became a star. That is the mythology of the Dhruva. We learn from our epics. Similarly, in our tradition, we say that when a person dies, when our ancestor dies, the ancestor becomes star. But no one ever tells that this person perished and become a planet. Okay? In our tradition, we say that a person died and become a star. I think here lies a hint. Why? Because a twinkling star probably said that something is alive because it's twinkling, something is going on, some change is happening. So, probably our ancients, with their pictorial imagination, when they saw stars twinkling, they saw maybe my ancestors is smiling at me, but might be signaling at me. So, although they did not refer to twinkling, but the idea that twinkling makes a cosmic object lively, probably that is the reason why uh, they said that when ancestor dies, she or he becomes a star. Of course, this is purely my speculation. On the other hand, planets in Indian context were not viewed as benevolent people. They were called grahas, meaning ones who created problem by grabbing. And that is the reason why you have to pacify the Navagrahas according to superstitions of astrology and horoscope. We have to pacify Navagrahas, particularly Shani, for our well being. So, planets were not looked up as benevolent objects, while stars were. And this is just my speculation. I see a comment by Shruti that energy is released. Probably she is referring to the thermonuclear fusion taking place at the core of stars. Yes, it is the energy released due to the thermonuclear fusion taking place in the cores of stars, which makes the stars so very hot. On the other hand, let me here mention that the hot lava of Earth, or the core of our Earth, being in a molten state and in a very hot state, here it is believed that the heat is coming due to various decay of radioactive nuclei at the core. So the process is somewhat different from what happens in stars. Let me come to Priyamvada's question. Uh, she's asking, yeah, here I must mention that we will talk about all that later when we talk about galaxies, that there are strong evidence that our galaxies are, although they are made up of stars and gaseous matter, no doubt, which are made of elements, the standard elements that we have discovered through our research in the field of chemistry and physics. But the dominant matter for the galaxies is not these standard elements, which are referred to as baryonic matter because they are made of baryons like protons and neutrons. But the dominant matter is actually some mysterious matter which have been termed as dark matter because no one has seen directly the dark matter as yet. In fact, dark matter detection is a very, very active area of physics research currently. So no one knows whether the dark matter are uh, particles weighing 100 giga-electron volts or higher, or million electron volts or lower. In fact, some people claim that dark matter could be axion-like particles, which whose rest mass is as small or even smaller than 10 to the power minus 20 electron volts. So, in short, dark matter is still mysterious. We don't know what the dark matter is made of. Only thing we know, or only thing we are certain, we will cover that later in our lectures, is that dark matter exerts gravitational pull, and it is from their gravitational pull on visible matter, like baryonic matter, that one infers the existence of dark. And indeed, uh, theoretical calculations based on observed motion of baryonic gas clouds tell us that the extent over which dark matter is present is 10 times larger than the scale over which stars and gases are going around the center of a galaxy. Okay? And the mass of total mass of the dark matter is in galaxies is also roughly 10 times the mass that is locked up in the gaseous and stellar system in galaxies. So the size is 10 times larger than baryonic matter extent of our galaxy. The mass is also more than 10 times the mass that is locked up in the baryonic matter in galaxies. Now, let me come back to Priyamvada Kameshwar's question. She says, based on the statement I made that the cloud, uh, the giant molecular cloud, as it shrinks, it undergoes gene instability and different parts, they fragment and they collapse again due to genes instability to form stars. She's asking, well, such a cloud would also probably have a dark matter cloud around it, and would dark matter cloud around such a baryonic matter cloud, would it affect the process of star formation? It's a good question, but remember that I mentioned that the dark matter which is deduced from its gravitational tug on other visible matter is spread over 100 over 300,000 light years in our galaxy. All right. So the density of the dark matter, if you find out the density of the mass density of the dark matter in our solar system, that mass density, or the better criteria is, take our solar system and over the sphere of our solar system, estimate based on the density of the dark matter, estimate the total mass of the dark matter. You will find that the total mass of the dark matter within the volume of the solar system is a tiny fraction of the total mass of the solar system when you add up Sun and the Jupiter's mass. So although the total mass of the dark matter, when you take into account the dark matter halo, whose extent is up to 300,000 light years, the total dark matter mass within a sphere enclosing the solar system, this solar system dark matter mass is negligible compared to the mass of the Sun and Jupiter. Although, when you take the dark matter extent up to 300,000 light years, the mass is huge. You might say, why is it happening? Simple calculation. Here, I would like all of you to do such simple calculation, that how is mass related to mass density and volume? Volume goes as length cube. Therefore, mass goes as density times length cube. So if the density is not changing much, the total mass will scale as cube of the length. So that is the reason why when you go up to a scale of 300,000 light years, then the mass of the dark matter dominates over the mass corresponding to stars and the gas in a galaxy. But when you take a small volume, like the volume of our solar system, then the corresponding mass of the dark matter within a sphere surrounding the solar system is negligible. Because, as I said, mass goes as density times length, a scale of the system cube. So cube, as you know, it if you double it, if you double the length scale, the cube will go eight times. You make it 10 times. If the length increases by 10 times, then the volume goes by 1,000 times. And that is the reason why, although density of dark matter is very small in our solar neighborhood, but when you look at the scale up to galactic halo scale, the total mass becomes extremely large. All right, let's go to next question. Well, Uranus, many reasons have been suggested as to why Uranus rotates in the opposite, as Shivangi has asked. It is a far flung planet. It's a planet at the outskirts of our solar system. So, probably it was an object that was not part of our original solar system. It could have been captured from another system. Okay. Or even if it was part of our original system, collision with some distant objects like a massive comet or a massive asteroid like body could have resulted in its spin angular momentum to have changed. So there are many theories which could explain why a far-flung object like Uranus rotates differently. We also know that Neptune's spin axis uh, is tilted by a great amount. So these can be explained by either collision with heavy objects or them being captured objects. All right. There are many theories. Yeah. So Dinesh is asking, when a star is born, then how to get the idea the star rotation is clockwise or anti-clockwise? Here we apply low star's direction upward or, well, as I said, the original direction of the star's rotation is linked with the rotation of the gas cloud whose collapse led to the formation of the star. And that's a initial condition. I mean, there'll be stars uh, rotating in one direction, there'll be stars rotating in other direction. These are, as I said, if a giant gas cloud with different parts collapsing into different stars and different tidal torques resulting into angular momentum, different angular momentum of different stars, obviously the angular momentum of different stars, not only they will have different magnitude, will have different direction. And some stars might be rotating clockwise and some stars will be rotating anti-clockwise. Okay. Clockwise and anti-clockwise direction is very simple. All you have to do is, if it is rotating, spread your fingers in the direction of rotation and put out your thumb. The direction of the thumb gives you the direction of the angular momentum. So the thumb rule only tells you the direction of the angular momentum given the direction of rotation. That's all. Shubham is asking, from the beginning till now of solar system, is there any change as noticed in the speed of planets around the sun? Well, Not really, because as I said, that the time scales over which the orbital size of the planet will change comes from two physical factors largely. One is gravitational radiation, which is very weak for planets. The other is the uh, energy lost due to the tidal forces. Here, I must say that what has been deduced is uh, that moon's distance from Earth has been changing. Of course, time scale of the change again is billion years. And as I mentioned in the previous lecture, why is Moon going further and further away at time? As I said, the tidal force of Earth on Moon caused the spin rate of Moon to decrease, so that now the spin rate is same as the orbital rate of the Moon. It is tidally locked, so that we see the same face of the Moon as the Moon goes around. But if the spin rate is increasing, where is the extra kinetic energy, rotational kinetic energy going? It's going into the orbital energy. Similarly, Moon's tidal force is slowing down Earth's spin. So, in fact, with time, Earth's day and night period is also increasing, of course, at a very slow rate. And here also, the kinetic energy, the spin kinetic energy, is going into the orbital energy of Earth and Moon. And hence, Earth and Moon, they are, as the orbital energy is increasing, they are becoming more and more distant from each other. I will come to Shubham's statement, but before that, I will take up Ankit Yadav's question. He asks that can dark matter be plasma? Well, it can't be very hot plasma, because if it is hot plasma made out of protons and electrons, they will radiate electromagnetic waves. Okay, and such electromagnetic waves can be detected. So it can't be hot plasma. And by definition, plasma cannot be very cold, because if the plasma is very cold, then ions and electrons will combine to form neutral atoms, and they can't be cold either, because they will be then cold dust clouds. And cold clouds, they are baryonic matter, and there is, from Big Bang nucleosynthesis and observation of light elements like deuterium and lithium abundance, one has a bound on the amount of baryonic matter that is present in the universe, and it falls short of to explain dark matter. But here I must explain there are caveats, and this is not the final word, what I stated. So one can't be very sure that baryonic, very cold baryonic matter as dark matter can be ruled out. But most likely, with greater confidence, we can say that baryonic cold dark matter, like Jupiter like planets spread all around, they are called, the so called uh, Jovian scale dark matter candidates. Uh, they have been proposed, but the likelihood is smaller. Okay. Shubham is asking, can you please change the afternoon class time? Yes, we can do that. You can suggest, can we shift it to some other day? I am agreeable if, yeah, I agree that 4 hours, 4 hours on a single day is a bit too much for everyone. So, yeah, I am amenable to suggestion. If you wish, we can take up some other day for the afternoon lectures of Introductory Astronomy course. Okay, so please think over uh, as to what would be a suitable time uh, for the second phase of the lectures on introductory astronomy. Please think over. Meanwhile, let me address some other questions. Yeah, here is Medha's question about Vedas having correctly um, describing four yugas, etc. Uh, Medha, let me point out that Rigveda doesn't talk about four yugas. It is the later uh, Vedic writings, particularly Puranas, which talk about yogas, etc., and they are speculative. I don't know what you mean by saying correctly described four yugas. There is no evidence, uh, scientific evidence, that there were four yugas in our cosmic uh, evolution of the universe. Yugas are related, uh, are linked to the Dashavatara of Lord Vishnu, that at the end of Yuga, uh, a new avatara is formed. But these are mythological and related to Puranic literature. These are not part of astronomy to begin with. There is no evidence that Kali Yuga uh, is was born about 3,000 or 4,000 years ago. There's no such evidence. These are all written from the perspective of poets. They have their own imagination, all right? And to your question about the scientific estimate of the age of the universe, well, 13 billion years is what has been estimated from actual observations of precision measurement related to cosmic microwave background radiation. They are very, very precise measurement. And as I told in the beginning of my lecture, the science is based on accurate measurements coming from experiments and observations. And therefore, anything that are not based on very good measurement concerning experiments, well conducted experiments, and well conducted observations cannot be part of the knowledge that describes the objective physical world that we are in. So, if someone wants to talk about the objective physical world, not imaginations and our feelings inside, that is a separate part. But if you want to know what our outside physical world is, we have to rely on a body of knowledge that is objective. Objective meaning it doesn't depend upon people's opinion, feelings, emotions, belief system. They are objective. If I do something, I get the same result as someone who is doing it in China, or someone doing in USA, or someone doing in Italy, or so on. If I drop an object and measure its acceleration, no matter whether I am in India, or whether I am in New York, or whether I am in Shanghai, or whether I am in Tokyo, or I am in London, wherever, I will measure it to be around 9.8 meter per second square. Such facts do not depend upon human emotions, belief, or imagination. Science is all based on that. Okay, Priyamvada is asking, what about primordial black hole as dark matter candidates? Yes, uh, because uh, various experiments have not found 100 gigaelectron volts dark matter candidates. People are slowly speculating whether dark matter could be made out of primordial black holes whose mass is few kilograms or even 10 times sun's mass formed in the early universe. People are talking about it and people are writing papers on it. So we still don't know uh, what the dark matter candidates are. There are models from axions to WIMPs to machos to primordial black holes. The whole uh, situation concerning dark matter is very, very open. Regarding Ankit Yadav's question, yes, as I said, that most of the stars are not only rotating around the center of the galaxy, but they are also going up and down in the z direction. So there are relative motion between stars, and they have been measured also, particularly those who do pulsar observation. Pulsars, because they are very, very accurate clock like systems, based on their Doppler motion, one can find out how far fast a pulsar is moving with respect to sun. Such measurements are there, and people have estimated the velocities of pulsars with respect to barycenter. Barycenter meaning with respect to center of the solar system. Priyamvada is asking, isn't the age of the universe model dependent? And isn't 13.8 billion years the result of flat lambda CDM? The answer is yes. But even if you change the model of the universe by tampering with the Hubble constant from 60 kilometer per second per megaparsec to 80 kilometers per second per megaparsec. Similarly, tamper the density of the universe from 10 to the power minus 28 grams per centimeter cube to even going down to 10 to the power minus 31 grams per centimeter cube. The age of the universe will lie between few billion years to 50 billion years. The range will not be very much big. So, in other words, the microwave background radiation and various other tests like supernova 1, standard candle test, or the present weak gravitational lensing studies concerning galaxies, they will change the Hubble constant to from 68 to 72 kilometers per second per megaparsec. The density of the universe can change from 10 to the power minus 31 grams to q times 10 to the power minus 29 grams per sec minus 10 to the power minus 29 grams per centimeter cube. But the age of the universe cannot become from a billion year time scale to a 10 is for 8 years time scale. For the simple reason, Earth, from radioactive studies made by the geologists, the Earth's age itself is few billion years. And therefore, the universe must have an age larger than few billion years. Shubham, the offline teaching, that means classroom teaching, may not begin too soon because the COVID 19 menace is still there, and therefore one doesn't know when the offline classes will begin. And therefore, uh, we have to assume that online teaching would continue uh, at least till December. So, keeping that in mind, please decide uh, whether the second phase of our lectures should be on Saturdays or should we have it in the afternoon of some other day, because forenoon we can't because it would clash with other courses. Please tell me, please uh, decide among yourself. But also, please tell me, should we have the 5 o'clock class today or not? Please discuss and tell me. Yeah, so Premvada is asking me, in cosmology, there is a term K which is related to the spatial curvature of the Friedman Lemaitre Robertson Walker model of cosmology. So K equal to plus 1 corresponds to a closed universe. K equal to 0 corresponds to a spatially flat universe, but expanding indefinitely and having an infinite volume. Similarly, K equal to minus 1 is ever expanding and a universe which is infinite in extent for all times. But no matter what the value of K is, ultimately the age of the universe is linked with the density of the universe and Hubble constant. They cannot cause too much of fluctuation because density of the universe from independent measurement cannot be less than few times 10 to the power minus 29 grams per centimeter cube. It can be larger, but then if it is larger, it can't be more than 10 to the power minus 28 grams per centimeter cube. So density and the Hubble constant, they decide the age of the universe, and the age of the universe, therefore, cannot be more than 20 billion years if one does a rough estimate. That is precisely the reason why qualitative statements are not important in science. One has to actually calculate, make estimate, so that one knows how much can you go, how much can you go beyond 13.8 billion years. Our experimental measurement of Earth's age itself says that the age of the universe cannot be less than few times billion years. That itself gives a lower bound to the age of the universe, and the upper bound comes from the value of the Hubble constant and the value of the density of the universe, which determines the value of the K. So, shall we take it that today we meet at 5 o'clock? If everyone is agreeing, at least today we can meet at 5 o'clock for 1 hour. So, we'll have 1 hour class at 5 o'clock today. All right? Great. So, I will now close this session, and please discuss among yourselves and let me know when you would like to have the second session of Introductory Astronomy course on a regular basis. Okay, so I will close the session. Thank you for being with the first session. Goodbye. We will meet at 5 o'clock again. Goodbye.